We've got a really quick video here about 3 tools that we're going to be using as we progress in a geometric proof. So these 3 tools are properties, and they're going to seem really basic, but you're going to have to trust me that they'll become useful later on. So the first property is called the reflexive property. So the reflexive property just states that any item that we have will be equal or congruent depending on the situation to itself. So for example, if let's say A is a number, so if A exists, then it'll be the case that A is equal to A. Very obvious statement, I know, but it's something that we're going to need. And this isn't just true for numbers, it's true for any of the things that we've talked about. So for example, if we have let's say we have a segment length, so if AB, if that exists, then it'll be the case that AB is equal to AB. All right, the distance from A to B will be equal to distance to AB itself. And this is also true for congruence as well. So if a segment exists, if AB exists again, then it'll be the case that AB, that segment, will be congruent to itself. And I could keep going with some more examples. It's also going to be true for angles. So if I have the measure of angle ABC, then the measure of angle ABC will be equal to the measure of angle ABC. Or if I just have that angle, if angle ABC, then angle ABC will be congruent to itself. So I could keep going on, and as we progress through learning more topics, it'll be the case for triangles or for any polygon or just anything along the way that we talk about. If we have something, it will be equal if it's a measure or congruent if it's an object to itself. So that's the reflexive property. The next property is called the symmetric property. And I won't list out as many examples this time. Let's just talk about numbers real quick. So if I have 2 numbers and they're equal to each other, if A is equal to B, then it'll be the case that I could rewrite this in the other order. So if A is equal to B, then B has to be equal to A. So symmetric, meaning that the symmetry here is that I can flip-flop the sides of the equation, or congruence, if that's what I'm talking about, that these 2 things are on. So I could do the same thing for congruence, for example. So if I have a segment that is congruent to another segment, then I could also write this as the other way around. So segment CD is congruent to segment AB. And I can do this for angles, I can do this for angle measures, I can do for the distance between 2 points. Again, I have a whole bunch of different things that the symmetric property applies to, but it just says that if I have 2 things that are equal or congruent to each other, then the reverse of that is true. So that's property number 2. And then property number 3 is called the transitive property. And this is the one which I think you'll think is most obviously useful. You can probably think of some ways that we could use this right off the bat. And it's going to be the one that we probably use the most. So it says this: if A is equal to B and B is equal to C, then it'll be the case that A is equal to C. So the way I think about this is that it's like I'm linking 2 things together. If A is equal to B, and what is B equal to? Well, B is equal to C. Well, then I can just go directly from A to C to say that those things are equal to each other. And this, of course, is true for segments as well. So if AB is congruent to CD and CD is congruent to EF, let's say, then it'll be the case that AB is congruent to EF as well. Okay, so this transitive property allows me to link things together. And in fact, I can stack the transitive property multiple times as well. If I were to know that, I had A is equal to B, and B is equal to C, and C is equal to D, and D is equal to, E, my bad, equal to E, then I can stack these all together and just say that A is equal to E, all right? And so again, the transitive property is true for angles. It's true for segments, true for measures, for distance, or for angles, or just numbers in general. So these three properties, the reflexive property, symmetric property, and transitive property, are going to be three properties that we kind of build off of, and are these really basic building blocks for proof moving forward.